Flack math! Give me some math and I'll give you some flack. Flack math!
So nonlinear functions. So in geometry, a point has 0 dimensions. It's just an exact location in space. A line has 1 dimension, so it just has length. Okay, so over here, this guy just has length. And then a plane has 2 dimensions. It has length and width. And then space is what we call 3-dimensional. Okay, and there's only one space. So space is not like stars and whatever. That's outer space. But space is everything else. Okay, we got another onliner. So these are nonlinear functions. So basically, oh, this is a linear function. So basically, nonlinear functions do not form a straight line. Okay, so let me give you an example. This is f of x equals ax squared plus bx plus c. This is called a quadratic function. And we've talked about this before, but this is like a trinomial that you can factor and things like that. So if I were to graph this, it would look like this, a parabola. Okay, so a parabola just kind of keeps going up at an accelerated rate, and we're going to do an example here of that, but you need to be able to recognize what these look like. So in your homework and on your possibly your next test, you're going to have to do a little match thing. Oh, this is a quadratic function. This is a cubic function. This is an absolute value function. And this is a square root function. So those are the 4 functions we're going to talk about today. All right, so let's just try to graph one of these functions. So if I did, oops, is that all I have for graph paper? All right, let me get something else on here. 1 second. 1 second. There we go. So if I wanted to graph this function, f of x equals x squared. Well, let's just try doing some xy values, just like we always do. Let's try x's and y's. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. Do you see how I'm getting these numbers? Just plugging in 2 right here. 2 squared is 4. Plug in 3 and you get 3 squared is 9. Plug in 4 and you get 16, and then it keeps going. Well, the cool thing about this, let me draw my plane here. So here's what it looks like so far. 0, 0, 1, 1, 2, 4, 3, oops, that's not 4. 2, 4, 3, 9, and then 4, 10, 11, 12, 13, 14, 15, 16, is like up here to 16. Okay, so here's what it looks like so far. All right, but here's the cool thing. If you plug in opposites, like -1, if I plug in -1, what am I going to get? I'm going to get the same thing as +1. I'm going to get 1. If I plug in -2, I'm going to get 4. If I plug in -3, I'm going to get 9, and so on. So -1 gives me that. -2 gives me that. -3 gives me that. And -4 would give me that +16 as well. So here's what it looks like. So that is called a parabola. Okay. All right. Now, the book calls this the parent function. So f of x equals x squared. F of x equals x squared. That's what that looks like. If I were to shift this is what it would look like. If I would do like, I think it talks about that. Did we get into that right away? Hold on 1 second. I don't. My notes are over there, so I'm coming out of the book right now. Okay. So note that the graphs of these functions are okay. So yeah, right. So basically, a a horizontal shift looks like this. If I went x minus 3, if I subtracted 3 first before I squared it, well, if I plugged in values, then I would get, okay, 0 would be negative 3 squared, which is 9. 1 would be negative 2 squared, which is 4. 2 would be negative 1 squared, which is 1. 3 would be 0. 4 would be 1. 5 would be 4. 6 would be 9. So basically, it's the same y values, but the x values are shifted over 3 units, okay? So see how we just shifted that 3 units over to the right, okay? So when you see something being subtracted from x, that's a shift to the right. Now, if I did this, if I did f of x, here, let me get a different color here. If I did f of x equals x plus 3 squared, well, what do you think would happen there? If this shifts to the right, this would shift to the left, okay? So this guy would look like this, okay? We can close that door if we need to. I got permission from Mrs. Shive to do so. So just first period because the orchestra is a little louder, but
Yeah.
all right, so do you see what's happening? This is called a horizontal shift. Now, there's another kind of shift. It's a vertical shift. So a vertical shift happens after the x is squared. So if I did x squared minus 3 here, so see how I'm not subtracting 3 before I square it? Then this guy ends up being down here. So see how they all look like the same parabola, but they're just being shifted. This is a transformation. Okay, so this looks just like the purple one, just down 3 units. All right, and then there's one more type of thing. This is just a, let's try this color. I don't know if it'll work. So f of x, ooh, that won't work. So let's try this fancy green. F of x equals negative x squared. Well, that just flips it upside down. So if you don't believe me, which I don't know why you wouldn't, but you can just plug it. You can just plug in graphs here. So 0 would still give you 0, right? 1 would give you 1, but then this negative sign makes it negative 1. So 1, negative 1, negative 1, negative 1, 2, negative 4, negative 2, negative 4. So everything gets flipped. All right, but you can recognize that just like when you have a linear equation in slope-intercept form, you see what the line does. You see where it crosses the y-axis and you see the slope. Okay, well, this is basically the parent function of parabolas. Okay, so these are all just different versions. These are transformations that happen. So if you add or subtract something inside the parentheses up to the x before you square it, that's a horizontal shift. If you add or subtract something after you square it, that's a vertical shift. If you negate it, that is a flip. Okay, so you're shifting, you're flipping, and yeah. So what else do we got? That's it for the parabolas. All right. The next function is called the cubic function. So the cubic function, quadratic function, I think we talked about this. Quadratic functions are weird because when I see the word quadratic, I think of 4, like quadrilateral, 4 sides. But a quadratic function has a degree of 2. So the highest exponent is 2. Cubic function looks like this. F of x, let's do a different color here. So f of x equals x cubed. All right, well, let's try some x values. So 0 still gives you 0, 1 gives you 1, but negative 1 gives you negative 1. Because if you plug in negative 1 times negative 1 times negative 1, that turns back to negative 1. 2 would give you 8, negative 2 would give you negative 8. So instead of the negatives going to the same value like it did in quadratic functions, they are going to the opposite values. So 3 would give you 27, which is off the graph here. -3 will give you -27. So 0, 0 is right here. 1, 1, -1, -1, 2, 8, and then -2, -8. So here's what a cubic function looks like. It's hard to draw, but basically it looks like this. Oh, I just did the same thing. Okay, so it looks like that. So it looks like the parabola. If there was an axle on the vertex, the middle, then you took one side and you twisted it like that. You know, like hyperextended, you just broke the arm or twisted it around. That looks painful. Okay, so this is a parent cubic function. So guess what? The same transformations would take place. So if I did x minus 3 cubed, well, that's just a horizontal shift. So now here's what x minus 3 cubed looks like, right? If I did an f of x equals x cubed minus 3, it would be down here. So it would go up like that, but then it would turn around and come down like that. Okay, you guys seeing what's happening here? And then I'll just do the one more here. F of x equals -x cubed. Well, that just flips it over. So here's what that looks like. Make sense? So all the shifts are the same, okay? And so you notice when you shift horizontally, it's like the opposite of what it looks like. So -3 means you're going to shift +3 to the right. And then a vertical shift is exactly what it says. So x cubed, after you graph it, you shift it down 3. So vertical shifts are exactly what's written. Horizontal shifts appear to be the opposite of what's written. Okay? So that is a cubic function. All right. Well, the next one is a square root function. Let's go down to our next graph paper here. Square root function looks like this. F of x equals the square root of x. All right, now, here's the deal with this, though. Remember, what's the one thing you can't take the square root of? I think we had this on the last test. What can't you take the square root of? Anybody know?
0.
You can take the square root of 0, because 0 times itself is 0. Anyone know? What's the square root of 9? 3, right? Oh, do you know, Elkin?
Is it negative numbers?
Yeah, you can't take the square root of a negative number because nothing times itself will ever equal a negative number. Not in the real world anyway. That's when we start talking about imaginary numbers in Algebra 2. Okay, so here's what this looks like. So this is kind of the opposite. This is like the opposite of a quadratic function. So instead of squaring, you're going the opposite direction. So like the y values become the x values and the x values become the y values. Okay, so really what happens, well, let's just plug in some points here. Let's plug in some x's and y's. I'm going to pick some x's that are perfect squares. So 0 gives me 0. 1 gives me 1. I'm going to skip to 4 because I can take the square root of 4. That gives me 2. 9 gives me 3. 16 gives me 4. Okay, now technically, it gives me 2 roots, right? When you take the square root of something, you always have the positive and negative version. But what's wrong with this? Why can't you have both? You guys know why? What's the rule of functions? You can only have one y value for every x value. So technically this guy would make it not a function. All right, but we're going to ignore that bottom half. We're just going to go with the positive roots, okay? Because otherwise this can't be a function. right? Because 1 would go to both 1 and -1. And we can't have that. We can't have x values going to multiple y values, okay? So there's that. Same thing, if you shift this, you're just shifting. So f of x equals x square root of x minus 3 would be right here, right? F of x of square root of x, f of x equals square root of x minus 3. Well, that would be right here, okay? And then if you flip it, same thing. You're just drawing it upside down. F of x equals negative square root of x. Then that looks like this. Then that is this function, okay? But it's not the top part. Does that make sense? If you ever forget these, you can always just plug in some numbers like we did in the blue there on the left. Just plug in some numbers and see what it looks like. But your homework and your test is going to be just identifying, okay, this is a quadratic function, this is a cubic function, this is a square root function, or this is the next one, which is an absolute value function. All right, well, this is pretty easy. Absolute value, where are you? There you are. So absolute value, so f of x equals the absolute value of x, okay? So let's draw our graph. That was impressive. Well done, Mr. Flack. So let's do some, so 0 goes to 0, 1 goes to 1, 2 goes to 2. All the positives go to themselves, right? But all the negatives go to the positive versions, right? So what does this look like on the graph? It looks like this. That's pretty easy. Just a 90-degree angle. Looks like a V. That's it. So again, all the shifts are going to be the same. So f of x equals x minus the absolute value. So see how it's happening inside the function, inside the actual operation? Well, that's going to look like that. All right. And then you got your f of x equals absolute value of x first and then minus 3. That's a vertical shift. Sloppily drawn. And then, of course, flipping it upside down equals negative absolute value of x. So you take the absolute value of x first and then you negate it. That's going to, oops, that's minus 3. So, and that's a good thing. I'm glad I did that because obviously you can do multiple things in the same thing. You can shift it horizontally, vertically. You can flip it. So for example, if I did f of x equals negative absolute value of x plus 2 plus 8. Well, what this is going to do is it's going to shift. Remember the opposite of that, left 2, up 8, and then it's going to flip. Okay, so if I were to draw this here, so left 2, blip, blip, up 8, 1, 2, 3, 4, 5, 6, 7, 8, and it's going to flip, then it would look kind of like that. All right, does that make sense? Yes, Mr. Flack, you're so smart. Love you. Okay, so there's some examples in your book. If you want to look at those, you can, but you're basically just, you're just matching, okay? So given the equations of the following functions, and you have to match which ones are the cubic functions, okay? So let's do that. I'm gonna draw something, and I want you to tell me if it's quadratic, cubic, square root, or absolute value. Okay, ready? Here we go. What's that? Quadratic. And you could also, bonus points, you could say it's a negative quadratic. So you could put a negative sign in front of it. Okay, good. What about this? Did somebody say something?
Yeah, Nathan said absolute value.
All right, you're absolutely right. See what I did there? Okay, what about this one? Did anybody say anything?
Nope.
Oh, what happened there? So it looks like a missile taking off, but it's upside down. Which one was this?
Square root.
Yep, square root, and it's upside down, so it would look kind of like this. And we don't know if it's shifted anywhere because we don't know where the origin is on the graph. So, but that's what your homework and probably your next test will look like. So that's it for 95. Let's go to 96. All right, now this is a cool one. We're still factoring trinomials, but this one, we don't need a graph on this. Okay, so here's lesson 96. We're going to talk about the difference of two squares. Okay, so obviously square root of 4 is what? It's 2 and a negative 2. Don't forget you have a negative version as well. Okay, so if I want to solve this equation, then if I take the square root of both sides, then I have x equals positive or negative 2. Do you guys remember this symbol? We're going to use this symbol, positive or negative 2. So that is the solution to that equation. Okay, but there's also, I think we talked about the difference of two squares, but let's do a real quick review. If I've got x squared minus x minus 6, how do you factor this? All right, we'll start with our cheeks and tats. And then what two numbers multiply to get negative 6 and then add to negative 1? The microphone might not be picking up.
Well, don't they say anything too definitively.
Okay. Yeah, so we have a negative 6, so it means it has to be a positive times a negative. And then they have to differ by 1 because when you add them together, you're going to get down to a negative 1. So let's see, negative 3 and positive 2 would give you that, right? Good there. But what if there wasn't anything there? What if there was like a 0x and a negative 9? Well, same thing. What two numbers multiply to get negative 9, but then when you add them together, they cancel out? You guys know?
3, negative 3.
Yeah, positive 3 and negative 3. Okay, so now you won't see anything like this because it's silly to write a 0x, right? So what you're going to see is called a difference of two squares. And we talked about this before. So whenever you see this, then, oh, this is one of those easy ones where I just take the square root of the first one and the square root of the second one. One of them's positive, one of them's negative because they have to cancel out. Okay, you guys remember talking about that? Maybe we did, maybe we didn't. But you can use that if you want to by solving these quadratic equations. So for example, if you have like, here's example 1. P squared equals 16. Well, I think you can probably figure out what squared equals 16, but don't forget, you need two answers. So if I took the square root, I would be positive or negative 4. But you could bring this over, subtract it, and you have p squared minus 16 equals 0. And then you can solve by factoring. P plus 4, p minus 4. So what p's will make this 0? Well, p has to be negative 4 or it has to be 4. So same thing. You don't have to do it that way. If it's easy enough to just solve it right away here, then go for it. But you could use the difference of two squares theorem. So that's it for 96. It's really easy. So you're just using that theorem. The theorem says if P and Q are real numbers, and if P squared equals Q squared, then P equals Q, or P equals negative Q. Basically, you just need two versions. Whenever you take the square root of something, you're going to have two answers. Okay? Any questions? All right. So, Mrs. Waite, sometimes we have some time left over, and we do have a lot of time left over. So if they want to talk quietly, they can, or they can work on their homework.
Okay.
And if they get, for every 5 problems they get done, then I give them what's called a Flack attack coupon. So guys, if you want to keep track of that and let me know, otherwise you can let Mrs. Waite know, and Mrs. Waite, if you want to just write down their names and how many problems they did, that would be awesome.
Okay, sounds
But
good.
yeah, sound good? All right, see you guys.
Black math, give me some math and I'll give you some flack. Black math.